All right, let's now talk about the chapter 5 prompt engineering. And this is a very interesting chapter, I think, because prompts are the core of many AI system, and the author defines a prompt in a very interesting way, like as a way to talk to your model and express desirable behavior from the input alone without changing the actual model weights. So you can think as a form of programming, like you're writing code in a natural language to activate some specific capabilities of the model, and again without changing the actual model weights. And she mentioned that we need to be very rigorous um, with these prompts, the same way that we are with any machine learning experiment. So we need to have systematic testing, versioning, and evaluation, so we can assure that we have a reliable AI system. Um, and the prompt engineering can be summarized like as a way to finding this right prompt that will activate the program that you want, the system that you want, and summarize. Um, that's it. What is like prompt engineering? Uh, Currently, there's some things related to context engineering, but I will not dig deeper on that. Um, but basically, that's what is um, this definition of prompt engineering from the beginning of the book. Later, we go much more about the anatomy of a good prompt. So basically, we need to have a task description, a system prompt, which will contain like high level instruction, setting the context, the role, the goal. For example, you are helpful and concise assistance for a tech support team. Then you go to a few shot learning step, providing more example, this showcasing the inputs and outputs expected, um, in the task itself, like the user prompt, which would be like a query from the user. For example, I can't print my wireless printer, and basically that will be like an use case um, for an anatomy of a end-to-end prompt definition. Um, there are some best practices talked in this chapter that I like to highlight. So clarity and reduce ambiguity. So be very specific and ambiguous in your instruction so we can guarantee that we can minimize the problems that we already know about the non-determinism of the LLMs. So be very specific and ambiguous. Another thing is anthropomorphize the model. So give you give it a role. For example, you're a brilliant Lego advisor. You're a brilliant investor. Uh, um, you're a you're a brilliant computer science programmer. This stuff, and provide examples. So we do not provide alone the instruction is not a good practice. So we need to showcase how it will act in the real world, so they can um, make this specialization and have a clear understanding um, about the task, and provide specific output format. So if you don't provide it, um, if you want to integrate this systems with other parts of the system infrastructure, it will be difficult. Of course, you can have like a parsing part, but you can add these responsibilities to the prompt also. And also, last but not least, provide sufficient context. So you need to think on how the needed information for that context of that problem, so we can mitigate hallucinations. So just to recover, hallucinations are basically when the model have a gap of knowledge about some situation, and it will fulfill uh, and we will fill that no that gap with or common sense or nonsense stuff. So you need to provide this context about um, high quality data and guidelines so we can minimize this stuff. More best practice mentioned in this part that I think they're important is break tasks into subtasks, which is the composition pattern. So if it's not like super good to have like a super huge prompt. So if you have like a intent classification, then the generation and the evaluation, you can break down these into more granular stuff, so you can minimize the problems of instruction following problems. So when you can like break this into smaller subtasks. Another thing is give your model the option to think. I think called chain of thought, which so you have these models that have this ability of thinking and evaluating this process in order to produce better results. So you can encourage these in the steps of the prompt to have this reasoning. For example, in the ChatGPT 5, we have options to have levels of reasoning like minimal, medium, or high, and that will have uh, encouraging in more better outputs from the models, but also more costs also related to this thinking. Another thing is iterate in the version of your prompts. So as we mentioned, we need to think of these prompts as a models. So you need to assure that what you are changing in the prompt can be seen as a new version of a model, and you need to keep track of these changes and on the trade-off, including on each change and what we are losing and what is the experiments that we are running for each one. And final, last but not least, like having evaluation tools. For example, we have OP prompts, prompt breeder, or TextGrad that will automatically fine tune your prompt and come up with alternative prompts. We also have the prompt optimization from OpenAI that will serve like auto ML for prompts, and that could be like an interesting way to iterate on the prompts. But that's not all the good things. We have some problems and security concerns with the prompts. So we have different types of attacks that could involve prompts. So the first problem is like prompt extraction, when the malicious attacker steal the system prompt to replicate or manipulate the app. Jailbreaking or prompt injection. So we need you bypass the safety filters to generate harmful content. And one of the example this is the do anything now attacks. For example, make a transfer to my account, blah blah blah. And information extraction. You can like trick the model to give you information that they're not supposed to give you to. And a bunch of other things, for example, data leaks, code execution, misinformation, and reputation damage. So this could all these breach in the prompt could imply these problems. So you need to assure that you have both input and output guardrails well established for your application if you want to go this to the to deliver this for the people. And what we have we have a lot of ways to defend upon that. For example, we have different layers in which we could approach this. The first part is in a model level, so you could fine tune the models to prioritize systems instructions and handle borderline requests with more safety concerns. In another level, you could attack this in a prompt level, so we can have like a session just for safety, like is splitting the restrictions, make the model focus on only in the instructions, be very aware of these type of attacks, so we can make sure that it will not uh, take into any of these case that we mentioned before. And last but not least, I think the most important is have system level defenses. So these guardrails that I was mentioning, we could like isolate this part, so we can, if the prompt call a tool, for example, you can having these to run this in a staging or a sandbox environment, so we can assure that these malicious action call will not like be propagated to your system. Another approach is having human approval, so request manual review for high risk actions done via prompt. Another thing is having guardrails, so filter both inputs and outputs of harmful content, and that could be like another prompt with a more well designed instruction for this harmful content definition. And last but not least, like have an anomaly detection, so we can flag any type of anomaly in the user requests, so we can keep track on these in a more granular way, and we could like make the trace back of these decisions. And as the author states, like AI safety is a cat and mouse game, so there's no bulletproof solution, but it is with this layer approach we can like mitigate most of the problems, because we have many parts of the info with this validation that we could assure that is harder for us to providing untrusted decisions for our AI system. Okay, I think that's it for the chapter 5, prompt engineering. Next we'll talk about a very important component of more robust and sophisticated AI system, which is the RAGs and agents, and that will be very exciting. But yeah, I think that's it for now. Thanks for watching, and see you in the next lesson.